All right. So what we're going to be doing here is something that you're going to do a lot of next year when you're in pre-calc. We are trying to take expressions and we're trying to simplify them. So we want to try to get them down to a single value, like a single trigonometric function, like we want to just get it down to sine or just a tangent or just a cosine. So what we want to be doing as we're trying to do that is we're going to replace everything. We're going to try to write everything in terms of sine and cosine, okay? So if I have tangent, looking at our paper, another name for tangent you can see is sine theta over cosine theta. So right here where I have tangent, I'm going to replace that with sine theta over cosine theta. This bar right here means divided by. So I have divided by secant theta. If I'm dividing, how can I change it into multiplication? Multiply by the reciprocal, right? So I have sine theta over cosine theta times the reciprocal of this is 1 over secant theta. What is another name, though, for 1 over secant theta? If you look at your paper, we know that secant theta is 1 over cosine, so we would also know that cosine is the same thing as 1 over secant. So what am I going to replace the 1 over secant with? Cosine. So now I have negative sine over cosine times, this is now cosine. And now cosine divided by cosine cancels to be 1. So our answer to this is negative sine theta. See, the way I know I'm finished is when I get it down to a single expression. See, right here I have a fraction. I don't want to have a fraction. Here it's even worse. Here it's worse. Once I get it to here, though, it's a single value, and that's how I know I'm finished. Alex? Good question. Next year you will have to memorize all of these. For this year, I'm going to give you a paper that's going to have this on it, as well as some other ones that we're going to do. So you'll just have to be able to apply it this year. Okay? All right, the cosine of pi over 2 minus theta. Look at your paper and tell me what that's equivalent to. Sine theta. So I'm going to replace this with sine theta. And then I have 1 minus cosine squared theta. In the warm-ups, what did we just say? 1 minus cosine squared theta is the same as sine squared theta. Here's the reason why. If I look at this Pythagorean identity right here, if I want to know what 1 minus cosine squared theta is, I subtract it from both sides. So 1 minus cosine squared theta had to be sine squared theta. So now I have sine theta times sine theta times sine theta, because this is 2 of them. So if I have that, what's that going to be? Sine to the 3rd theta. So that means the sine of theta cubed. The reason they don't write it like this is because what do you think that kind of looks like? That theta is getting squared, right? So this is defined as theta getting squared. This is defined as the sine of theta, or cubed rather, getting cubed. And I know I'm finished because there's nothing else I can do with it. It's down to a single value. All right, let's look at number 7. So the first thing you always want to try to do is to factor out a greatest common factor if you can. So looking at this numerator, 2 secant squared x minus 2 tangent squared x. What is the common factor there? 2. So I'm going to factor out a 2. In the denominator, we have tangent of negative x. What's another name for tangent of negative x when you look back at your list? negative tangent x, right? Looking at another name for cosine of negative x, what's that going to be? Just cosine x, right? Remember what I said is the best way to do it. The first thing you always want to do is to look for Pythagorean identities. Is secant squared x minus tangent squared x equal to anything? If you look back here, secant squared theta minus tangent squared theta would just leave us with 1. So right here, this is all just 1. So 2 times 1 is 2. Remember I said to get it simplified, anytime you have a function, you want to write it in terms of sine and cosine if you can. Tangent is going to be negative sine, because of this negative, over cosine. Then we have times this cosine. What can I do? Cancel the cosines. So now we've got negative 2 over sine x. I want to get it so that I don't have division. I don't have fractions. So what's another name for 1 over sine x? Because remember, this would be negative 2 times 1 over sine x. Looking at your sheet, what's 1 over sine x? Cosecant. So this would be negative 2 cosecant x. And I'm finished because that's just a single value, no fractions. It's simplified as much as possible. Any questions so far? All right, let's go on to number 8. So we're going to look for sine of pi over 2 minus theta. What is it? Cosine. And there's a negative here, so it's going to be negative cosine theta. Now, secant of negative theta. Do you see a secant of negative theta on your list? So how can I rewrite secant as what? 1 over cosine. So now I have 1 over cosine of negative theta. I still have this minus sine squared theta that I haven't even worked with at all yet. Well, what is the cosine of negative theta? Just equal to what? It's equal to just cosine of theta. So I have negative cosine of theta over 1 over the cosine of theta. Now, I don't want to have this complex fraction. So to get rid of that, I can just multiply the bottom by cosine theta and the top by cosine theta. You're allowed to multiply by 1. Cosine over cosine is 1. That's what I'm multiplying it by. So these cosines now cancel, and what are we left with then? Negative cosine squared theta. And I still have that minus sine squared theta. Now let's look back at our identities. On our identities, kind of written over top of mine, I'll write it over again. On our identities, I know sine squared theta plus cosine squared theta equals 1. So I want to know what's negative cosine squared theta minus sine squared theta. I'm allowed to move this stuff around as much as I want, but I'm also allowed to multiply it through. Like I could multiply the whole thing through by 2, or by 3, or by 5, or by what would be helpful in this case? Negative 1, right. If I multiply this whole thing by negative 1, I'm going to get negative sine squared theta minus cosine squared theta equals negative 1. And so what is another name for this? Negative 1. And that's a much simpler way to write this whole thing. So this whole thing is just the same thing as negative 1. If I were to plug in a value for theta and do all this work, I'm always going to get negative 1, no matter what value I plug in for theta. Any questions? All right, so on these we're simplifying. See, look at our answers. A single value, a single value, a single value, and a single value. Next, we're going to be verifying the identity. This is kind of nice because they're telling us what the answer should be. They're saying the answer to this should be that. The answer to this should be that. But we have to prove it. See, verify means the same thing as prove. So looking at this right here, we want to think of a way to do this. Can anyone think of something that we could do with this to try to make it look like that? Is there anything you know about it? Alex? Sine squared? Yeah, good. So 1 minus cosine squared is sine squared theta. And then we still have over secant squared theta. I can only work with one side of the equation. So I've chosen the left side, and I'm going to have to stick with the left side and make it equal that. Any other ideas on what we could do? What's another name for 1 over secant? It's cosine, right? So if I have 1 over secant squared, I can make that into just cosine squared. So 1 over secant squared would be cosine squared on the top. What can I do now? If I have, this is one of my terms, and this is another one of my terms. Any ideas on what you can do with those two terms? Hunter? Okay, good. I'm going to factor out the sine squared, and now I'm left with cosine squared minus 1. Do we know another name for cosine squared minus 1? Let's go back up here to our identity again. Sine squared theta plus cosine squared theta equals 1. We want to know what's cosine squared theta minus 1. So I would have to subtract 1, and then I would have sine squared theta plus cosine squared theta minus 1 equals 0. I want to just have cosine squared theta minus 1, so what do I have to do to both sides now? Subtract sine squared theta. So cosine squared theta minus 1 is negative sine squared theta. You should always be thinking, is that going to be helpful? So if I replace this with negative sine squared theta, is that going to be helpful? Yeah, sure. So now I've got sine squared theta times negative sine squared theta. So this is sine times sine times sine times sine with a negative. So it's equal to negative sine to the 4th theta. And we're finished. Once I make it match, that means we're done. What questions do you have on that? See, this is going to seem difficult at first because you've never done anything like this. But once you start working through the homework, you'll get pretty good at it. I'll tell you, number 29 on the homework is very challenging. Some people did figure it out in 4th period, and they were so proud of themselves because it's tough. But you got to stick with it. It's one of those where they're going to tell you what the answer is, and you have to keep on working until you can get it to match that answer. All right, we're going to do number 10. This one's a lot tougher. Guys, you can choose either side to work with, but you have to stick with the side that you choose at the beginning. I always say, Alex, what? Because in a proof, you don't want to change like one side It's just kind of like mathematicians have always said, if you're doing a proof, you're only working with one side and you're trying to make that side equivalent to the other. So, because if you cross multiply or go across that equation, then you're assuming that it's equal, and we don't want to assume that it's equal. We're trying to prove that it's equal. Okay, but guys, what you want to do is work with the more complicated side. This side is pretty easy. This side is more complicated. So let's jot this down. Work with more complicated side. Do you see how on this one, the more complicated sign just happened to be this left side that I worked with? So that's what I'm going to do here. Which side do you think is more complicated? The right side, yeah. Now, there is really nothing I can do with this right now. But there's a little trick that you can do that will always make it so that you can do the problem. And it is to multiply by the conjugate. You can multiply by the conjugate of the numerator, and you can multiply by the conjugate of the denominator, whatever's the most helpful. There's nothing I can do with this right now, and that's because of this. Let me show you something here off to the side. Everyone knows we can't write this as sine x over 1 minus sine x over cosine x, right? Would you know that? You wouldn't try to do that? Okay. So that's the problem, is that I have two terms down here. And I want to get a single term so that I can split it up. See, look, if I have 1 plus 3 over 4, I can write that as 1/4 plus 3/4. You see how that would give me the same answer? Okay? But if I have 4 over 1 plus 3, that is not equal to 4 over 1 plus 4 over 3. See how that would not be the same thing? So I can't split it up. That's what I'm saying. Like, there's nothing we could do except multiply by the conjugate. The conjugate just means to change the middle sign. So instead of doing 1 minus cosine x, I do 1 plus cosine x. So I'm going to multiply at the top. Sine x times 1 is sine x, plus sine x times cosine x is sine x cosine x. On the bottom, 1 times 1 is 1. The outers are plus cosine x. The inners is minus cosine x. The last times the last is minus cosine squared x. Well, look here, in the positive cosine x minus cosine x just cancels. And so then I'm just going to have sine x plus sine x cosine x over 1 minus cosine squared x. What is 1 minus cosine squared x? Sine squared. So now I'm going to have sine squared x on the bottom. What can I do to the top, guys? What can I do if I have this term and I have this term? What can we do with that? Factor out a what? Sine x. Let's go ahead and factor out a sine x. If I factor out sine x, what are we left with? What's sine x divided by sine x? 1 plus sine x cosine x divided by sine x. What is it? Cosine x. So now I've got multiplication. See, this denominator, sine squared x, means sine x times sine x. So I can now cancel. I can cancel that with that. So at this point I have 1 plus cosine x over sine x. Look back at what we're trying to get. We're trying to get cosecant x plus cotangent x. What should I do now to get that? What's it?
1 over sine x is
You're right. And then because both of these, like, remember what I showed you here, 1 plus 3 over 4 is 1 over 4 plus 3 over 4. So this is 1 over sine x plus what? Very good. So, and now this, good, right. So this is cotangent, and this is cosecant. See how we got it finally? We got it to match up. That's what we're trying to get, cosecant x plus cotangent x. And that's what we have, cosecant x plus cotangent x. Once we get that, we are finished. This is something you've just got to practice, and you've got to be looking back to what you're trying to get. This is a big clue, though. Whenever I have like 1 plus sine x or 1 minus sine x, I want to multiply by that conjugate, because what's going to happen is it's going to simplify down to something that's going to be helpful. All right? So you guys have your problems up there. Like I said, they're not too bad. I think they're going to seem easier than this to you. This is tough. This last one was very difficult. But hopefully this one made pretty good sense to you. And then as you're working through it, just really try to make sure you're replacing with something that's equivalent. Why don't you guys go ahead and get started on that. Try to get a couple done, and I'll walk around and help you if you need it.